Yes. Hello, everybody. Multiplicity, huh? I'm gonna do some more practice. All right, did the introduction, right, to multiplicity last time. Then did a couple intro examples. Today we'll get into it a little more. You know, some other types of examples. All right. So let's see here. All right, so we'll start to mix it up, right? So I did, 6 and 7, some intro examples. So this is page 22. I'm definitely going to do number 8. And then, definitely we'll do all or some on page 23, just letting you know. And probably not all, but some on 24. So a lot of examples here. I don't know how many I'm exactly going to do, but let's start with this one. All right. X plus 3 multiplied by x minus 1 quantity cubed. Little FYI here. I don't think I mentioned this last time. The exponent will tell you whether it's odd or even multiplicity. Right? X minus 1, that factor, is raised to the power of 3, right? So you'd write it out, 3 times, set that equal to 0. You'd have x equals 1, 3 times, right? So that's odd multiplicity. You can use the exponent to determine whether it's going to be odd or even multiplicity. All right. So yeah, we're going to have some odd multiplicity there with x minus 1 because it repeats 3 times. All right. So what is the degree of this polynomial function? Well, you got 3 x's here with x minus 1, and then you got 1x here with the x plus 3. So if we were to multiply it out, you'd have the 1x with the x plus 3, and then the 3x's from the x minus 1. You multiply it, right? And it would start off x to the 4th. If we were to multiply this all out, it would be x to the 4th. So this is a degree 4 polynomial function with a positive leading coefficient. Right? Like I said, you could put the, it's a 1. You can write 1 there if you want. The y-intercept, if you remember, we put in 0 for x. So 0 plus 3 multiplied by 0 minus 1 cubed. 0 plus 3 times 0 minus 1 cubed. Negative 1 cubed is negative 1 times 3. So we're going to have a y-intercept here at negative 3. Okay. And zeros and their multiplicity. So negative 3 is going to be a root, right? You said x plus 3 equal to 0. You get x equals negative 3. That's a simple root. That's not a repeated root. So you just write negative 3 and you go on to the next one. Right, x minus 1 is the factor, which means you set that equal to 0, you're going to get 1 as your root, which is repeated 3 times, right? So that is a multiplicity of 3. That is your odd multiplicity. Remember, graphically, odd multiplicity at that root that repeats an odd number of times is going to have a point of infection. I guess, I got this pandemic on my mind, I guess. Inflection, right? A point of inflection, not infection. Inflection with an L. Which is the point where the graph changes concavity. Right? Changes how it opens. All right, so we have a degree 4 here with a positive leading coefficient. So that is the general shape, right? The general shape of that is a W. That's the general shape. All right, so let's plot the points here. We have a y-intercept of -3. We have a 0 of -3, and then we have a root, right, of 1 with odd multiplicity. All right, so here we go. It's going to be, somewhat of a W-shaped graph here. The point of inflection is going to not make it look like a standard, W as I have, drawn there. So like I said, this is the general shape of a x to the 4th. All right, so we're going to start, up here in quadrant 2. It's going to come down, right, to that root, -3. And, once again, at -3, you want to see, is there any multiplicity there? If there's no multiplicity, that's a simple root, meaning it goes straight through. All right, so it's going to go straight through here. It's going to go to the next point, which is the y-intercept. Right there at 0, -3. And then it's going to go to the next point, which is x equals 1, that root. Now remember, that's where you have odd multiplicity. That's where you have your point of inflection. So it's going to come up, right? Remember, it's going to sort of level out and then go straight back up. Like I said last time, it doesn't level out there, but the rate of increase is not as fast as it was, past x equals 1, right? If that makes any sense. The y values don't increase as fast, when you have a point of inflection in that area around the point of inflection. The y still increases, the y values, as you go from left to right, but it's not as fast. And like I said, it's just it's the point where the graph changes how it opens, right? You don't need to draw this in, but, over here, right, it was opening downward, and here it's opening upward. So that's the definition of the point of inflection. All right, and now we answer as x goes to infinity. So over here, this is x going to infinity. What's happening to y? Over here is x going to negative infinity. All right, in both cases, the y value is going to infinity as well, right? Those arrows are pointing up. Right, as x goes to infinity, y goes to infinity. As x is going to negative infinity, remember over here, this is x going to negative infinity. The y is going to infinity, not the x there. All right. So in both scenarios here, the function, and when I say f of x, they mean y, is going to infinity. All right, so there we go. It's a good one. All right, number 8, people. Let's do another one here. All right, let's do 9. 9's a little interesting because people get a little confused by that GCF out there. All right, so number 9 is x times x plus 5, that quantity, squared. So you have, once again, you can use this exponent here to determine, right, that you're going to have even multiplicity. That root is going to get repeated 2 times. So we're going to have that x, right, that GCF guy, and then you're going to have 2 x's there with the x plus 5. So if we were to multiply that out, the first term here would be x cubed. So this is a degree 3 polynomial function with a positive leading coefficient. The y-intercept, you put in 0 for x, all right? This is going to be interesting here. 0 times 0 plus 5 squared. 0 times 5 squared, right, is 0, right? 0 times 25 is 0. That's interesting, right? Y-intercept of 0. The cross, or the, it's going to intersect the y-axis there. It has a y value of 0. All right, so where on the y-axis do you have a y value of 0? 0, 0, right? The origin. Which means 0 is going to be a root as well, right? You got x, and then x plus 5, if you want to write that out 2 times, to get the root, you set those factors equal to 0. X equals 0, x equals negative 5, x equals negative 5. So 0 is a root. It's a simple root, but it is a root. And then negative 5 is a root with a multiplicity of 2. Right, that's even multiplicity. All right. So a degree 3 with a positive leading coefficient is going to end high, right? Remember, a degree 3 or any kind of odd degree polynomial function, the end behavior is different. One end is up, the other one is down, and vice versa. So remember, I use the leading coefficient to help me in terms of how it's going to end. Positive leading coefficient, it's going to end high, start low. That's how it's going to look. That's the general shape. of a positive XQ graph. Start low, end high. All right, so let's give this a sketch, right? So the origin is a point, right? It's the y-intercept and the x-intercept here for this graph, and then -5 has a multiplicity of 2. Now remember, even multiplicity, right? Even multiplicity, people. It's tangent, right? It's tangent to the x-axis at that root, so remember that. That's even multiplicity. It's tangent to the x-axis. So it's going to start low, end high, so it's going to go to -5. Now remember, it's tangent, right? Hits it, and then it goes right back down. Right? That graph right there is tangent to the x-axis at -5. Right, it's going to come back down, and then it's going to go to the next point here, which is 0. 0 has... it's a simple root, so it's going to go straight through and then, go up like that. Like I said, guys, it's a sketch, so it's not, it's not going to be perfect, which is fine. I forgot to mention in the last one, and I think I did it with the intro example, if you're point of inflection doesn't look like a point of inflection, you could just label it. And that would be fine, even if it doesn't look like a point of inflection. If you label it, that would count. All right, now we got to answer the end behavior. This is x going to infinity over here. This is x going to -infinity. What's happening to the y values? As x goes to infinity here, the y is getting bigger as well, right? The y is going to infinity. As x goes to -infinity over here, the y value is going down, right? To -infinity. So as x goes to infinity, y is going to infinity. And as x goes to -infinity, y goes to -infinity. All right. So there you go, people. All right, that's one with the GCF there. I think I might do this in the next one. I'll hold off. Yeah, I want to do an x. That's a 5er. I want to do that, and then maybe one more. We'll see. All right, so I'm definitely going to do number 10 on the other side here for sure. And then maybe one more, like I said. There's a lot of examples here. We don't need to do all these, so yeah.